So 1.2, question number 10. And I believe this is another interest question here. So we're looking again at simple interest. And in this case, we want to find the simple interest. So we don't need the total amount. We only want the simple interest. And we want to find the simple interest if $800 is borrowed at 17% for 6 months or a half of a year. When we look at time, time has to be in years. So we're going to use that 0.5 for the years instead of the 6 months. If you've got months, you've got to convert it to years. So our formula is the same as what we had before break. I equals PRT. P is again the starting amount of the principal. And in, and in this case, we start off with $800. We have a percentage rate, R, of, 17%. And as a decimal, we want the decimal equivalent. Move it over 2 spots. So that's 0.17 as a decimal. And then we've got our time. Now we don't use the months, we use the years. So our time in this case would be 0.5. We don't know the I, that's the unknown component. So put everything together. And then we simply just multiply across. All right, so we've got 800 times 1.7 times 0.5, and that's going to give you now $68. And so we owe $68 in interest. And that's what we want. We don't have to find the total amount because it just wants the interest. The questions in the next section are a little bit more difficult because those are going to be coming up with our own formulas and drawing diagrams and pictures that relate to that. So the next section has questions like this, but they're more in depth. 13 is next. And this is a distance question. So for question 13, Jay drove 355 kilometers at an average rate of 71 kilometers per hour. How long did his trip take? So we want our formula for the back cover. Just so I can reinforce where it's at. It's at the bottom here under other formulas, and we're going to use the distance formula. D equals RT. So distance equals rate times time. And so let's see what we know. J drove 355 kilometers. So that means my D, which is the distance, is 355. The rate of speed. Do we know the rate of speed? Yes, so average rate of speed is 71, right? So R is our rate of speed, and that's 71 kilometers per hour. And then the time is what we don't know. So we don't know the time. So let's put our pieces together, and we've got 355 equals 71t. We'll divide by our 71. And then that leaves us with our time here. 355 divided by 71. And that comes out to be 5. Now, what's our unit here? It's time, right? Okay, now time can be measured in minutes, hours, seconds. Ours is going to be in terms of hours. Why? Because what's our rate of speed in? Kilometers per hour, right? Units have to match. So if the rate of speed is kilometers per hour, time better also be in hours. So 5 hours is going to be your answer there. And please make sure you label your answers on these applications. 17 is next. Okay, and 17 is a percent problem. And what we're going to try to figure out in this case is what percentage of our sales were spent on delivery costs. So we've got West End Florist, and they spent $73,740 on delivery costs. If the total sales were $577,500, what percent of the total sales was spent on the delivery costs? And we're going to round to the nearest tenth of a percent. Now, when we talk about percents, that's two places. We want tenths, so we're actually going to take it out 3. That way, when we rewrite it as a percentage, it's tenth of a percent. So we want 3 places, 2 for the percent, 1 more for the tenth. Now, on this one, all we need to do is divide. So we want to find our percentage. So our percentage is just going to equal how much we spent on delivery costs, which was $73,740. And we're going to divide that by our total, which is $577,500. And this is going to give us what percentage of our budget of the sales was spent on delivery costs. Now, we want it 3 places, 2 for the percent, 1 more for the tenth. So we'll go ahead and divide. And we're going to round here. And we'll go ahead and round. And that's going to come out to be 0.12 if we round 8. Or 12.8%. Whenever you have a percentage, that means we divide. And we look at what we're dividing it by, which is our total, and how much we spent. And that's going to give us the percentage of our budget, or of the sales that we used to pay for those delivery costs. One more before we move on to the next section, question 20. Now, we talked a little bit about area and perimeter last time. Now, 19, remember, we were measuring around the amount of trim that we would need for a window, right? And if we look at trim, like these boards here along the wall, those are measured in feet. And that's a perimeter. Measure how many feet we need to go around. That's going to be in terms of feet or inches or whatever it might be, but that's going to be a perimeter. Okay? Distance around. So we look at distance around, that's the perimeter. Now, in this case, when we go to buy floor tile, well, what are we measured in? What is it? It's usually in square feet, right? If you go to the carpet store or the tile store, they're going to say, okay, this is how much this tile or this carpet costs per square foot. When it's square foot, that means it's an area. So when we're looking at this one, if we want to go buy tile, it's not going to be perimeter, right? We're not just adding up the sides of the room. No, we have to take the length times the width. So in this case, when we go to buy tile or carpeting, we would want it in terms of an area because it's square feet. Carpet is measured in square feet. So just to make sure, on question 20, it's going to be an area. Nothing to calculate. It's just a matter of noticing, is it an area or is it a perimeter? Perimeter, we add up all the sides around, and that's measured in your base unit, like measuring trim, that's in feet. When we do tile or paint or carpeting, it's in square feet. So that means it's an area. So that now is going to finish up 1.2. Do we have any other questions out of 1.2 to look at before we move on to 1.3 today? Anything else? Okay, hopefully, by looking at some of these questions, hopefully this kind of gets us on the right track. We now should be able to hopefully have a good skill set on solving equations. And we talked a little bit about the formulas and applications. 1-3 are applications that you probably have seen in previous courses, but we're going to go over them again. These are going to require us to make diagrams in a lot of cases or come up with our own equations. So we're going to start looking now at some applications out of 1-3. And there's many different types of applications in 1.3, and I'm going to try and do several of each type. So let's now go ahead and just look at a couple of these. And we'll start with just making sure we understand the terminology. So let's start with, I'm on page 87. Let's start with question 18. And if you don't have your textbook with you, that's fine, because I'm going to put this up on the screen when we read the questions. First thing I always do is I read the directions. Very, very important that we read the directions so we know what to do. And so it says, translate each verbal sentence into an equation using the variable x, and then solve that equation. So if we're looking at an equation, that means we've got an equal sign. So we need to make sure we understand what these words mean in terms of a symbol. Question 18. We'll read it, and then we'll go back through and pick out what each piece means and write our equation from there. I always like to read it through once. Then we'll go back and we'll look at it in piece for piece. If the quotient of a number and 6 is added to twice the number, the result is 8 less than the number. And we want to try and find the number. So what are we looking at on this one? We are looking at if the quotient of a number and 6. So let's start with that. Number and 6. So what would that be? Quotient of a number and 6. Do we know the number?
No.
No? So quotient means what? Quotient means divide. So the quotient of a number and 6 would be x over 6. So there's that piece. Is added to twice the number. So we're going to add, and what are we going to add to that? Twice the number, so that makes it what? 2x. So you've got that. Now, when we say result is, that means we use the equal symbol. And what does it equal? 8 less than the number. Okay, so 8 less than the number. So what are we doing here? Okay, yep, taking it away. So I'm going to write my x first, and what are we going to take away from that? Yep, 8, right? Because it's 8 less than the number. Not the other way around, because that 8 is coming off. So that means it's going to be negative, and I usually put it at the end. I like to write the variable first. So now we're at this point. We can solve it. So what do we need to do? Clear our fractions, and how do we do that? Multiply everything by what? 6. Okay, so multiply everything by 6 here. And that gives you then 6 divided by 6 is 1 times x makes it an x. Okay, 6 times 2 makes it 12x here. Okay, and then the other side, we've got 6x, and then 6 times a negative 8. 6 times a negative 8 would make it a minus what? 48, isn't it? Now we can finish it. So we can put these x's together here. I'll go ahead and do that. That's going to make it now 13x on the left-hand side. Right-hand side, I'm just going to copy. I'm going to move that 6 over. And we've got 13x minus 6x. That makes it a positive 7x equals that negative 48. They do not always come out to be whole numbers on these. So it can be a fraction. This one comes out to be a fraction. So what do? We divide by 7. And that leaves us with our answer to be x now equals a negative 48 over 7. So there's your final finished answer. I'm going to write with that so far. So we went through, we identified the different pieces. Quotient, again, means divide. When I say product, what does that mean? Product means multiply. Let's look at another one. Question 20. This will be the last one of these. Question 20. I picked this one just to make sure we understood our percentages. When 75% of a number is added to 6, the result is 3 more than the number. Now, whenever we have percentages, we need to convert these percentages to a decimal. Whenever we use them in an equation, those percentages have to be first converted to a decimal. So what are we looking at? We are looking at 75% of a number. And we know that 75% as a decimal would be 0.75. Right? So we did that. And we are looking at 75% of a number. That of means we're going to multiply. So that's going to be 0.75x. Have to attach the x there. Because it's 75% of a number. So that means we have to put the x with it. We're going to add that to 6. So we're going to add 6 to that. And the result is, that means equals.
3x.
Yep, 3 more than the number. Okay, so 3 more than the number would be, yep, x plus 3, wouldn't it? Not 3x. It would be x plus 3 because we're adding 3 to that number. Now we've got it. Now we can solve it. Be very, very careful when you work through these x's with the decimals. If it helps, put the 1 in front. Sometimes it makes it easier when you put that 1 in front, and if you write that as 1.00x when you move it over. That way you won't make a mistake, because a lot of times I see students make a mistake with the decimals. So if it helps, put a 1 in front, and just write it as 1.00. That way you can just subtract down. We know that the 1 is larger. It has a negative sign. So that's going to be a minus 0.25x. Plus 6 equals our 3. We're going to move our 6 over with subtraction. And that gives you now minus 0.25x equals a minus 3. Divide by a negative. Now, what do we know when we have a negative divided by another negative? Negative over negative makes it positive. So we know our answer is going to be positive. And let's just use our calculator to divide it out. And we've got 3 divided by 0.25. And that comes out to be 12. So our answer in this case would be 12. Where students make a mistake at is it's easy to write those decimals incorrectly. Take your time with the decimals and the fractions. Don't ever hesitate to use a calculator. If you struggle with decimals or fractions, use a calculator. Clear the fractions and then plug the decimals into your calculator. The next questions that we're going to look at are going to require us to use some formulas. So like we used in the previous section, we're going to go back to our back cover of our textbook, and we're going to find the correct formula. And we're going to apply that formula, and then we're going to use that to get our answer, and then make sure we answer the question. A lot of times what we find is not the answer to the question, so we have to go back and do an extra step. Let's look at, how about question 33? And this again is on page 88. We're going to look at question 33. What we're going to do is we're going to read it through. Then we're going to go back, try to think about what we're doing, what formulas do we need, fill the pieces in, work it out, answer our question, and make sure we label our answers. So the Bermuda Triangle supposedly causes trouble for aircraft pilots. It has a perimeter of 3,075 miles. The shortest side measures 75 miles less than the middle side, and the longest side measures 375 miles more than the middle side. We want to find the lengths of the three sides. Now, we could look up the formula for the perimeter, but the perimeter is always the same. The formula for all these perimeters is going to be the sum of all the sides. And this is question 33. So it doesn't matter what figure you're looking at. Square, rectangle, triangle, octagon, doesn't matter. When we talk about the perimeter, what are we doing? Adding up the sides. So that's just a basic definition. You could look it up in the back cover of your textbook. But all you really need to remember, perimeter means add up all the sides. Simple as that. Doesn't matter the figure, they're all done the same. Now, when we look at this triangle, what do we have for the triangle? It says that we've got three sides. Okay, so we have a short side, middle side, and the longest side. And that again is going to equal our perimeter. Now when I work out these type of questions, before I start plugging in variables, I like to use words, because that helps us understand what we're really looking at. So we know perimeter is sum of all the sides, and we know this triangle has the three sides, a short side, a middle side, and the longest side. And we know that perimeter is 3075. So we'll go ahead and fill that in. Now over here, let's see how all of these relate to each other as far as the sides. So we know, we'll work with these here in a moment. But we know our perimeter is 3075. And how do they relate to each other? So we've got a short side, middle, and a long side. Now again, we're going to use words first and then plug in the variable. So when we read this, it says the shortest side measures 75 miles less than the middle. Now we don't put units of measure on until the very end. So what do we know about the short side? Short side is going to be the middle minus 75. Okay. That's what it is in terms of the other side. And the longest side measures 375 miles more than the middle side. So the longest side is going to be the middle plus 375. And one of these is going to be called x. So something is always going to be called x, and that's the one we know nothing about. Well, we know nothing about the middle. So we're going to go ahead and call the middle x. Now we rewrite it so everything has the variable in it. So we wrote it in terms of words first. I think that's very important. And now we're going to fill it in with the variable. So the short side, what was that? Middle minus 75. And the middle we called x. So the short side is x minus 75. Middle side, we know nothing about, and that's already been labeled x. And then the longest side, we know that's the middle plus 375, so that's going to be x plus 375. So again, I like to split my paper in half, and this is my work over here, and this is my equations and solving over here on the left. So now that we've done that, we can fill it in on the left. So what do we know? We know the short side is going to be x minus 75. We know the middle side is unknown, so that's x. And we know our longest side, well, that's x plus 375, isn't it? Now we have it. Now we can solve it. We can find x, and then we can make sure that we answer the question completely. So combining like terms, it looks like we've got 3x, and we've got a negative 75 and 375, so it makes it a positive 300. And that equals our 3075. We'll move our 300 over. And now we've got 3x equaling, we'll subtract off here. 3075, we're going to take away that 300. And that leaves me with 2775. And we'll divide by 3. And that leaves me now with 925.
That's a lot easier when you put it like that.
Yeah, if you write out in words, it makes it a lot easier. Now, we have not answered the question yet. So what do we need to know? What does it want specifically? We've got to go back and read the last part. Find the lengths of all three sides. So this is x, and x was the middle. Well, we want the short side. So what's the short side going to be? Okay. Yep, the short side was 925, because that's our x value, minus 75, and the short side then came out to be, what, 850, didn't it? Because 925 minus 75, that gives you 850. So the short side is 850, and we'll label that in terms of miles. So there's the first piece. Then we need the middle. The middle's already done. The middle's x, so that's just 925 miles. And then what about the longest one?
925 plus 375.
925 plus 375. And that makes it, what, 1,300, doesn't it? Let's see, 925 plus 375. Yep, that comes out to be 1,300 miles. And there is our answers. We have to get all three of them. So we've got 850. There's the short side. We've got the middle one, it's 925. And we've got the longest one, that's 1,300. Is everyone okay with how I did that? I went through, I figured out this is a primitive problem. I wrote it out in terms of words, and then I filled it in with the variables, with the variable x. Now let's do another one. A little bit different on the next one, but still similar. Question 39. Okay, this one works with a total, and it's going to be similar to question 33. A little bit different, but solved pretty much the same way. So that was 33. We're now going to look at 39. And this one's going to work with the total. Perimeter was just a total, right? When we talked about the perimeter, we added up all the sides. So it was a total. All the sides got added up. Same concept here. These are actually a little bit easier. In 2017, two popular brands on Instagram were National Geographic and Nike. National Geographic had 8 million more followers than Nike, and together the two brands had 158.8 million followers. How many followers did each brand have? Just like the perimeter, we have a total. And we know that our total is going to be the Nike plus National Geographic. So there's our base part there. Nike plus that National Geographic gives you a total. Now we know the total, when we put them together, that total is 158.8. We're going to work on this one exactly the same as we did the last one. The last one was that triangle, and we got all three sides. We broke them out. We used words first, translated them into an expression with the x, put it back together, made our equation, and we solved it. Same thing here. So we know we have a total. And it says National Geographic had 8 million more followers than Nike. So we're going to say National Geographic is Nike plus 8. We're not going to put the million on. We're just going to use the 8 there. We'll put the units of measure on at the end. So just so we have less confusion, instead of writing 8 million, we're just going to put the 8 there. Now, what do we know about Nike? Do we know anything about Nike? No. So that's going to be defined as the variable x. Now we can rewrite it. National Geographic is Nike plus 8. Nike is x. So that's x plus 8. And Nike is x. Very, very similar to the previous question. Only instead of a perimeter, we've got a total. Now we can fill it in. So what do we know about National Geographic? Well, it's x plus 8, isn't it? And we know that Nike is going to be what? X. So now we've got it. We've got our equation. We can solve it. And we want to make sure we answer the question. So we want to know how many followers each of these has. So we're going to find our x, and then we'll find the followers for National Geographic and also the followers for Nike. So we'll add these together, and that's 2x plus 8 equals that 158.8. We'll move our 8 over with subtraction. So now 2x equals 150.8. We'll divide by our 2. And that gives us then x equaling now what? X equals, when we divide 150.8, divide that by 2, we end up with 75.4. We need to make sure we answer the question. So what does that 75.4 go with? Nike. Okay, so let's go ahead and get each one. What about National Geographic? Yep. It's going to be 75.4 plus 8, and that gives you now 83.4 million. And we'll put the units of measure on now. And then what about Nike? Nike was just X, so that's easy. Nike just has 75.4 million. Easy enough. We've got them. We've got the label. And we answered the question completely. So is everyone okay with that? So we wrote it out in terms of words, and then we plugged the variables in. Next, we're going to talk about percentages. When we have a percentage has to be linked to something. The easiest example is sales tax. We all have to pay sales tax, right?
Yep.
So let's say I want to go buy an item and it's marked on the shelf as $100. And let's say our sales tax rate is 10%. Now I'm not going to just pay $100, I would pay $110. Why? Because at $100, I have to take it times the 10%, right? Which that's $10 in tax, and then add it back to the total, to the amount. So when you look at the percentage of your taxes, what happens is you increase the value. If that item would have been, instead of 100, if that item would have been 500, then your tax would be what? $50, right? Instead of just 10. So the tax rate is going to be linked to the value of the item. So when we look at percentages, it has to be multiplied by something else. Percentages are never just randomly added to something. They are always multiplied by something. So whenever you have a percentage, it has to be multiplied by something else, always. When we set these up, we have to take that into consideration. So let's look now at question 42. So when we talk about these percentages, we're going to have to write them as linked to something else. And we're going to come up with equations for these. So move it up so we can see here. And these sometimes students struggle with, but once you see how to write them out with words and plug the pieces back in, they're not that difficult. It's just a matter of remembering a percentage has to be linked to something else. So question 42. The U.S. population reached 321 million in 2015. And it is expected to reach 347 million by 2025. What percent increase is expected over this period of time? And we want to round it to the nearest tenth of a percent. So that's 3 places. That way, when we rewrite it as a percent, 2 for the percent, 1 for the tenth. So 3 places. Now, what's happening to the population? Is it going up or is it going down? Population in the United States is going up, right? So it's an increase. We're going to, again, write this in terms of words. And this is question 42. Now we're starting with 2025. Okay, so that's going to be where we want to end up at. So 2025. Now that's going to equal the population that we have in 2015 plus 2015 times some percentage. Okay, that's your increase. When we have a percent, that percent has to be linked to something else. So we're going to use a percentage symbol. You can use an X. When you plug it back in, we'll use an X to represent that. But now we've got it. So this is where we start at. We add on a percentage. That's like your sales tax. Right? The larger the population is now, the more it's going to grow. So that's why they're linked to that percentage. It has to be linked by multiplication. So what do we know about our numbers here? We should be able to fill in a lot of this with the different pieces. And then we're going to use X as the percentage. So we're just going to replace that when we write it in. X is going to be our percentage. I think it makes it easier to write it like this, and then we plug it in. So what do we know? Let's try to figure out the pieces. 2025, do we know that? Yep, that's 347. 2015, do we know that number? Yep, 2015 is 321. And then we've got 321, and we're going to let x represent the percentage. So x is going to be the percent. So we're going to put that down as an x there. Now we can solve it, right? And when we work with these percentages, they're going to come out as a decimal. You're not going to get a whole number answer. They're going to be a small decimal. So we filled in our pieces here. Move that 321 over. And I like to rewrite it so the variable's on the left. So I'm going to rewrite this now as 321x. So that's going to come over. And then on the right-hand side, what do we have? We have 347 minus that 321. And that comes out to now be 26. Right? So I just wrote the 321x on the left because I like to write it on the left. You could write it out in 2 steps, but I like to do it in 1. And now we can finish it by dividing by that 321. And that should now give us our value. We want it 3 decimal places. So 26 divided by 321. And we're going to round this to 3 places here. So that's 0.08 if we round 1. And as a percent, that's 8.1%. So that would mean the population is expected to grow at a rate of 8.1%. So see how we did it. Think about it as going to the store and buying an item. This is the item. This is the tax on that item. This is how much your total bill is. Right? Same thing. Always you got something added to a percent, but that percent has to be linked to something else. It can't just be by itself. It has to have that variable x attached. Let's do another one of these. 44. On Major League Baseball opening day in 2016, the payroll for the Cleveland Indians was $87.2 million. In 2017, it had increased 44.3%. To the nearest tenth of a million, what was the opening day payoff of the Indians in 2017? So let's try to come up with our equation here. Now, what's happening with our percentage? Is it increasing or decreasing? They're making more money, right? So that's an increase, so that's a plus. What do we want to find? We want to find how much they made in 2017. And what they made in 2017 is 2016 plus 2016 times a percentage increase. That's just like your job. If you get a pay increase and it's a percentage increase, the more money you made before, the higher amount you're going to get paid extra. So now we plug it in and we see what we have and what we need to find. Do we know the 2017 number? Nope. So that you can put an X or you can leave it as 2017. I'll probably put an X just so we don't get confused there with the 2017 thing. It's a number. So X is the 2017 amount. And do we know the 2016 number? Yep, 2016 was 87.2 million. So there's that. And then we've got 87.2 million again. And we know our percentage. What's our percentage here? 44.3. So they increased by quite a bit. And 44.3% is 0.443 as a decimal. Is everyone okay with how I did that? So this is what we want to find. We want to find how much they're gonna make, or not make, but how much they spent on their salaries. And so we took what they made, or what they got paid the year before. They got a percentage increase, so that goes here. And we have to link that percentage back to what they made. And now when we solve it all out, we'll just use our calculator. And this is going to give us then our final answer. So you can break it up in pieces in the calculator, or just type it in as it is. So 87.2 plus 87.2 times 0.443. You can do that all at once. And how far does it want us to round? It wants us to round to the nearest tenth of a million. So that's one place. So that's going to come out to be 125 point, if we round 8. And so our answer would be 125.8 million. So think of it as a sales tax problem. That's all it basically is. When you go buy an item, you've got the item's price plus the tax, which is a percentage of that, and that gives you your final answer. One more, and then we'll take a short break here. 47. We'll do 47, and then we'll take a short break, come back, and try to finish up this section. Question 47. Again, this is another percentage type of problem. And this one is actually working with sales tax. And we talked about it. This is just an application of that. At the end of the day, Lawrence found that the total cash register receipts in the motel where he worked were $27.25. This included the 9% sales tax rate charged. Find the amount of the tax. So let's think about what we got. We've got a total, and that's going to equal the sales plus the tax. And how do we find the tax again? The tax is the sales times some percentage. So what do we now know? Well, when we read this question on 47, we know that at the end of the day, when you open up the cash register drawer, you found $27.25 in there. Do we know the sales? No, we don't know how much he really sold. So we're going to call X the sales. So that's going to come down as an X. And then what about the tax? Well, the tax is, what's our tax rate? Tax rate looks like it's 9%, isn't it? Okay, 9%. So as a decimal, that is 0.09. So it's going to come down then as 0.09x. You've got to attach the x to it. Is everyone okay with that so far? Does it make sense what we're doing? Now we just add them together. Make sure when you add these together you're careful. Remember, this is 1 here. So that's going to add together to give you 1.09x. And that's 2725, and you could flip them around if you want. Doesn't matter. We'll go ahead and divide. Now, what's my sales going to be? You've got 2725. We're going to divide that by 1.09. That's going to come out to then be 2,500. But that's not what I want. What is this? This is the sales. We want the taxes. So there's a couple of ways we could get the taxes. We could either subtract them, or we could just multiply. Let's just go ahead and multiply. Now the taxes is going to be 9% of the sales. So your taxes would be that 2,500 times 9%. And that then comes out to be $225. So that's what you're going to have to pay in taxes, right? Now, it should make sense because it should all equal each other. So if I take my 2,500 in sales and I add the 225 to it, what do I end up with? I end up with that 2725, right? And isn't that what it should be? Yep, because it should add up, right? Because the sales plus the taxes should give you the total, and they do. I could have also have just gotten this by saying 2725 minus the 2,500, and that would still give you the same thing. So you can either get the taxes by multiplying, then, or just subtracting it off. But that tells you how much I should have to give the government for the taxes. Let's now go ahead and take a short break, and we'll meet back here at 10:40. So meet back here at 10:40, and then we'll try and finish up this